My talk is on taking your SIEM to the next level with third-party tools and scripts. I'm super excited to be here. Justin had asked me to speak here, and I was very excited to. So thanks for hosting this. And let me turn on the clicker and make sure it works. 1 second, sorry. Yes. Okay, so who am I? So I'm the guy in all the Net Wars posters. I'm here.
That's who you are.
I'm here. Yeah. All right. My day job, I'm the Chief Security Research Engineer at a company called IronNet Cybersecurity. My primary focus is behavioral analytics, and I'm excited to jump into the whole machine learning debate, and we're gonna have a lot of fun in the SIEM tomorrow. But I study behavioral analytics and apply them to use cases all day long. So you talk about trying to detect beaconing, DNS tunneling. I'm working with data scientists to try to discover what new algorithm or what new analytic can we create to deliver to clients. I'm also in the Maryland Air National Guard. I serve as a cyber warfare operator there. I'm on a cyber protection team. So I'm primarily blue team for the military. It's the best way to think of it. And as Justin mentioned, I also work with him over at HA Security Solutions. I have a blog. It's austintaylor.io. And I also have a Twitter account, Hunt Operator. So what is next level? Yeah, I had a hard time coming up with the topic, but I really wanted to try to apply some definition of what next level means. To me, it just means that you've already taken the steps inside of your SIEM to help provide as much content and as much context for your analyst. So you've already asked the next 5 questions, and you have those questions answered inside of your SIEM when it's time, when it matters. So this talk specifically is going to focus on beaconing detection and vulnerability scans. With a couple open source frameworks that I wrote. So we're going to spend the remainder of this talk talking about your SIEM, which I'm sure all of you are using ELSA. I'm just kidding. Sorry, Doug. Yeah. So we're going to use for this demonstration. We're going to talk about ELK. That's the SIEM that we're using for a lot of these demos, and actually we're going to use the methodology that we're applying to this SIEM. You can hopefully use to whatever SIEM you have. So I know there's a large list of SIEMs out there, but most of them have an API. It's just not exposed. So we're going to talk about how to use the API and then use your SIEM for non-conventional purposes. To get all of our data, we're going to be using Python and Elasticsearch. So Elasticsearch has a Python framework that we use to retrieve the data. And then we're going to be doing some type of manipulation and then pushing that back into the SIEM for your analyst to analyze. Elastic's API in Python, so you'll notice here I've had a few questions like, oh, that's great, you have Elasticsearch. How do you pull that data out? This is an example boilerplate query you can use. There's a helpers method or a helpers module that the Elasticsearch framework uses. And what that helpers method has is a very helpful method called scan. And what scan does is there's a scroll function inside the Elasticsearch API, and you can set a timer for how far you want to scroll through it. And so in this case, we're setting it to say, hey, retrieve, pretend I'm like scrolling for 90 minutes. And what it will do is return all that data. So you can say, I want to pass this Elasticsearch query, which is the query up top, and then my client is the client where you're running Elasticsearch, and then run that query and it'll retrieve, you can specify what index you want to retrieve data from, and then you get all that data back. And when I first found out about that, I was really excited because you essentially you get a free database, right, using Elasticsearch, and now you can take this data, put it back into Python or your language of choice, which is probably Python, and then do whatever type of manipulation you need to do, and then provide this data back into your SIEM or provide it back to your analyst. So most SIEMs are focused on getting data in. We are going to talk about that a little bit, but we're also going to retrieve data through the SIEM's API, enrich it, and then reprocess it. That's what we're focusing on here today. Flare is an open source framework. So basically what I try to do, in my day job, I'm writing little enrichments to help filter down. So I'm a big believer in applying machine learning, and I've learned just through trials and tribulations that you can't just use machine learning on its own, right? You have to have machine learning and then apply domain expertise on top of that to really get those high fidelity, low false positive rates. So with Flare, I have stuff in there like, the Majestic Million, the Alexa top 1 million. I update those as much as possible. And I also have some cool stuff in there where you can take IP addresses and then map them to ASN numbers and then do like IP address enrichment, which is cool. There's pre-calculated formulas in there, like I got the Levenstein distance. So if you want to look for stuff like phishing. I also have another, one of the analytics that I wrote, so Justin's writing this course, Sec 555, it focuses on SIEM. He's like, hey, I need something to detect beaconing. And I was like, I think I can help you. So put together a beaconing analytic specific to Elasticsearch. And what it does is it retrieves all the data. I'm gonna jump into it in a second, the specifics. And then it looks for beaconing type data that is easily exported and we can create alerts on. So there's a lot of stuff in there. I want to give a special thanks to Justin for some of the inspiration with Flare, and then another one of my colleagues named Jonathan Burkert. I'm always trying to keep this up to date, and I'm always looking for enrichments, so please feel free to contribute. So this is what the Flare ini file looks like. It allows you to configure you can set up a host or whatever host you have that's running Elasticsearch, whatever the port is. And then there's some specific settings that are specific to detecting beaconing inside of Elasticsearch in here. So you'll notice the minimum occurrence, the minimum interval, and then the minimum percentage for your beaconing thresholds. Because we all know when you're looking for beaconing, all you have to do is just look for anything that has a hard set interval of like 30 seconds, and then you'll get back all the bad stuff, right? No, so there's network jitter, there's latency. Some things look like they're pseudo-random beaconing, so they don't actually have hard set intervals. Maybe they'll introduce something called jitter, like with plus or 5 - seconds, to try to throw off any type of basic analytic that will look for hard set intervals in beaconing. Another nice thing in here is it's a critical one. It's the threading. So I found that when I first wrote this, if I just ran it on a single thread, it would take forever to process, like retrieve all the data and then crunch through it. But by allowing a user to set threads, you can process it much faster. So if you leave that to 8 and you only have 4 cores, it will break. So that's a good setting to change. You also want to specify Kibana version. So today it supports Kibana version 4 and 5. Eventually we're going to do 6. I'm hoping to have that done this week. Oh man, I guess my battery's getting low on this clicker. Okay, so this is what the beaconing data looks like. So we're trying to identify beaconing. Inside Kibana, you have a few fields to work with, like time, IP address, ports, and protocol. There's a simple way to detect beaconing that we're going to use, and then there's a more complex way to detect beaconing. So the complex way is to use discrete Fourier transform over fast Fourier transform, and then push that in like a distributed clustering system in like Spark or some system that can do distributed computing. The simple way, and I've tested both of these to see what the efficacy of the results were, just take the source IP, the dest IP, the dest port, and then generate a hash, and then calculate the inner arrival times, and then do a count on that. So once you have that, then you get an output of results. And so those settings that I was talking about earlier, where it says what's the minimum times that this has to occur, one of those settings was 10. So it's saying only show me beacons that occur 10 times inside my network, and then you can output that in a CSV. This is, I was running this, so I did take the screenshot using Selks, but I have tested this on Security Onion as well. So you just pass in the config that you want to run that you've already configured, and then you can output this into HTML or CSV. I ran this on my home network, and initially I got 108 events to process. Then Justin was like, hey, it'd be cool if you could just focus, like create an outbound focus. So I did. And all it does is it basically filters out anything that's on the source IP address. It's anything that's RFC 1918, so all your private IP address space. and it filters out broadcast to the destination, because you get a lot of beacons that just beacon the broadcast to do like SSTP and trying to discover new devices on the network. That significantly reduced the amount of events to process. So now we're down to 31 events to process. There's also another method, some really nice methods that are in there. You can enrich your IP address and see who owns that IP space. And you can also group. So the grouping works with HTML, and this is what it looks like. So I use pandas and data frames, and then I output this to an HTML format. What this is the output from one of those runs, and you'll see it has a source IP, a destination who is, and then a dest IP, dest port, and then some really interesting metrics to help you determine if something or not could be malicious. It's artifacts that add context, right? One of those, I've heard a lot of people talk about, let's identify all the unique communicators on this network. So there's something called degree, and that is, if everyone in this computer probably has a computer, how many of the devices in this room have talked to that destination IP address? And that's what we're looking at in destination degree. So in this example, I have a destination degree of 3. You'll see that top IP address. It's funny, too, because the bottom 2 results are Google DNS servers. So to generate these results, I just ran a curl a few times to my blog, self-promoting, right? And then I did it in 60-second intervals, and it generated all these beacons, and I was able to pull out, this is what the result from that looks like. Another very interesting metric is the lower number is more interesting. I'll say more interesting. Hard to quantify like better, not better, but it's definitely more interesting. Because the likelihood of something being malicious if everything in this room is talking to the same destination IP address is a lot lower. The percentage is also interesting in here. So of all the traffic that went to those IP addresses from that source IP address, that's the percentage. That's the amount of traffic that was beaconing. That's what that represents. So 97% of the traffic that went to that destination IP address was beaconing. Also another interesting point, right? This helps you kind of narrow your search down. So you can just punch that IP address into Kibana, and this is what it looks like. You got to filter in a little bit, and then you get this nice distribution of traffic, and this is what a beacon looks like if you've never looked at one in Kibana. So another method to output this is you can write this beaconing out into a CSV file and then create a log stash filter and reread that file in. And then you can start doing some really fun stuff. So it's not practical to create an alert each time you see a new IP address, right? Because you get new IPs all the time. What can you do? A practical approach that I found to whitelisting new beacons is to first aggregate. So you take the source or the destination IP address, and then you figure out what the ASN is, because once you have the ASN, that usually registers, that IP block of space is registered to that ASN. Then you can start creating whitelist on who owns it. Anytime you get a new ASN that pops up inside of like a last alert, you can have it send you a notification in Slack or something and say, hey, just want to let you know we're seeing new beacons to this destination ASN. It's new. That is conveniently inside of Flare. So I take routes and BGP dumps that are publicly available, and then I also take ASN mappings that are publicly available, and then just join those, make it a convenience function. So you can just pass in an IP address, get the ASN number, or get the person who owns that IP space. So in this example, we're doing 8.8.8.8 because everybody knows what that is, and you can see that Google owns that IP space. So saw this morning. So maybe the person who wrote your product made it work that one time, but I don't care unless you make it work here. So I don't want to be that guy that just comes up here, shows you this great thing, and then it's like, doesn't even scale, can't use it anywhere. So I wanted to put a disclaimer in here This is not suited for large enterprise networks. However, I have tested this on a network with 10,000 nodes at 10 gigabit per second capture rates for over a 24-hour period, but my machine had 64 gigs of RAM. So it is also dependent on the machine that you're running it on. For small to medium-sized enterprise, I would say that this is suitable to get this incorporated. I already mentioned it currently only supports Elasticsearch 5 and below. I am working on doing like CUDA core integration. So if you have a MacBook, you can use the GPUs inside of your book to do parallel processing. And now you have 1,000 cores to process all this beaconing traffic. And currently, I've tested it with Suricata, Flow Records, and Bro. I have not tested it with any other sources, but those fields that are inside of your index for Elasticsearch are configurable. So these are the actionable next steps for beaconing. Identify those new beacons to ASNs and create whitelist on those ASNs. Create alerts using ElastAlert for new ASNs, and then I don't know what type of alerting system you have. I've seen a lot of people that use Grafana. I find Slack to be great to just have a channel where I'm like publishing new alerts to just, because I don't want to sit there. I can log in and check to see if I got any new alerts in my SIEM, but if I'm getting notified when it's happening, that's a nice convenience. And also, if you have any problems with the framework, submit a PR, right? So give back. Or create an issue and just really give back to the community. So that is beaconing, and that's my little piece on behavioral detection for beaconing. Now we're going up to level 2. So does anybody in here use Nessus? A few people. Great. Awesome. So there was a challenge that was kind of put in front of me that was, how could we take all of these Nessus scans and then create a timeline of, let's take all the history of all the Nessus scans, and then we'll put it into Elasticsearch, right? So challenge accepted, and obviously there's a dashboard in front of you, and I'm giving a talk on it, so it worked. So we created something called VulnWhisperer. This is a joint project between Justin and I. It's free and open source. It currently supports Nessus, and it works very similar to the way that Flare does, in the sense that all you have to do is go to an ini file and configure it. The beautiful part about VulnWhisperer is it's very modular. So I'm currently writing to ingest Qualys scans as well. And I have never used Qualys till I've had to write it for this, and it is brutal. Have you guys used Qualys? I mean, it's good intentions, but the user experience leaves a lot to be desired. Anyone work for Qualys here? Okay. It's okay. We can talk later. So the beautiful part here is custom risk scores. So I'm going to talk about that, and then tagging your assets. So you can tag your critical assets if you're in the health industry, anything that has HIPAA. It's intended to make actionable data. That's also for free on there, and we are working on a Docker version for this, or some type of Vagrant image, because there is a lot to set up. So to set up your environment, all you have to do is specify what port Nessus is running on. Username and password. Another guy named Sean McCullough, he just submitted a PR to actually overwrite that in the ini file, so you don't have to leave your sensitive credentials inside the ini. Now you can just pass it as parameters if you want to run it from command line. Your write path of where you want to export all your scans to, and then the database path. So one thing we built in is we didn't want to have duplicate data. So the VulnWhisperer database will ingest all the scans, and then it tracks metadata to see like which scans have already been processed. This is what it looks like when you run it, sort of. So you tell Python. So when you install VulnWhisperer, it installs a binary file onto your machine. This just happens to be on Windows, so you just pass it what config file you want to run, and it'll say, I'm attempting to connect to Nessus. Success, I was able to connect, so that means your credentials are correct. And then I connected to the database here, and I'm going to gather all the scans. And what it does is it uses Nessus's export feature for export CSV, and it not only pulls your current reports, but it'll go through and pull historical reports for so let's say you have a weekly scan. This can go through and pull the last 30 reports for that single scan. Why is that cool? Because now you can track risk over time for that scan, and you can say, this was the exact moment when this system got patched. We use something called swim lanes to do that, and I'll show you that there. One of the key elements here is, you'll notice at the very bottom, all these files are coming in. Oops, let me see. So on the left-hand side, we have, you have your finance office, your HR office, and then the management network. What am I doing here? So we're adding the names we're adding context to the scan name. So when you go in and create a scan in Nessus, you can say, I'm going to create a scan for my management network. And I'll show you why that's cool in VulnWhisperer in a second. I'll just give you a little hint. What it allows you to do inside Kibana is you can click on your HR office and say, show me all the vulnerabilities for my HR office. Right? So that's one example, but you can apply it to your specific use case. Yes?
Does it also support Tenable, the security center, or is it just Nessus?
This is Nessus. The question was, does it also support Tenable Security Center or just Nessus?
So this specifically is for all the individual scanners themselves.
Yeah.
If you have 10, you run it across them. But if you have Nessus Enterprise or Security Center, it's still the same API.
Okay.
I know it is for Enterprise. I believe it also is for Security Center. But the whole point of this is for those of us who can't afford Security Center. Just saying.
No, I have both, actually.
Oh, okay.
So that's why.
Okay. So the TLDR there was, those who cannot afford Security Center, this is for you, right? Justin said actually that Security Center was probably going to kill me after we created this because it works really well and it scales. So these are the steps for VulnWhisperer. So it connects to the Nessus API, exports all the results, write those to disk, and then ships the results off to Logstash using file beats from a single computer. Then it prepares the data and enriches it inside a Logstash, forwards it out to Elastic, and what it gives you is this beautiful prioritized list of vulnerabilities for you to go through. And I put the little image of Mr. Robot on there going, yes, because that was the feeling, that was the sensation that we got at 3 in the morning when we realized this was working. It's sad. All right, so the ingest workflow here, you're going to ship file beats. You're going to ship all the files off using FileBeat. That's all that your Nessus scans. The magic, where a lot of the magic happens, is in Logstash, and all of these configs are available on GitHub. And then when you view it, you're going to view it in Kibana, obviously. So there's something called Grok filters that we use to break out and then enrich the file names. Not a lot of people think to name your files in a certain method to add context, when it's in the user interface. So this is an example of one of the scans that get output, and there's color coordination happening there for how the Grok filter works. But essentially what it does is it takes the scan name, takes the scan ID, and then the history, and then last updated, and then those are fields you're going to have available to you inside of your Nessus index. So this is a question I could pose to the group. Today, could you tell me which site has the most critical vulnerabilities using your current vulnerability scan? Some of you probably could, right? You could break it up by site. You could just only allocate certain subnets to a certain site and then run that scan. If you're using Enterprise, it has a feature that's similar to that. This is what it's going to look like inside of VulnWhisperer. So you have your home office LAN servers or home office workstations or just whatever. You can break this up very granular, and then you can click on a specific name for whatever name you give your scan, and then it'll repopulate all the dashboards. I mean, that's how Kibana works. It'll repopulate all of the little dashboards to show you which vulnerabilities are present inside of those sites. So how could you answer this? Okay, the first one was a softball. Show me all of my HIPAA assets that have level 10 risk scores of services we don't whitelist that belong to our finance office. No? Maybe? Maybe you could, right? Take a few extra steps. So there's custom risk scores. So CVSS, every time you launch a Nessus scan, you get back those nice CVSS scores. Sometimes initially it looks like your entire enterprise has level 10 vulnerabilities. And it's a little nerve-wracking. But what if you don't use those services? Maybe you're whitelisting a few services like Adobe or Java. And even though that you're getting a CVSS score of level 10 inside Nessus, you really don't want to make that a prioritized list of things to go mitigate because you don't need to. It's already been mitigated in one form or another. So this is one of the great things that Justin did inside Logstash is he wrote this filter that takes the risk score. So it's saying if the risk score is not equal to 0, in other words, it has a CVSS score already assigned to it. If the plugin name is Adobe or Java, what you can do is divide that by 3 arbitrarily. Right, arbitrarily assigned to 3, but that will take that risk score down to a 3 or a 4. So that's a custom risk score specific to your organization. Here we're using Java or Adobe. You can take that and apply it to your own organization to help create that prioritized list of mitigations or mitigation actions. This is the output. So on the left-hand side, you have your CVSS scores. On the right-hand side, you have your risk score, and the risk score is the terminology we're using for custom risk scores specific to your organization. Out of the box, this, if you were just to take the CVSS scores, on the left-hand side is what you would get. So you get this large count of all the plugin names, and you can see that the top 5 results are all Adobe Flash Player. Well, we already talked about that's whitelisted inside the browser, so we're not running that inside our organization. So if you do it by risk score, now you have things that are actionable that you can go give to your SOC, and they can start mitigating right away. Another beautiful feature in Kibana is this feature called, it's a plugin called Timeline. I think it's built in now. But this literally allows you to track risk over time because you've already kind of quantified what is risky to your organization. Now, and since we're pulling in all the historical Nessus scans, we can track that risk and then get a nice little chart for the manager. So do you scale? Yes is the answer. This one does scale. We run it in a very large enterprise, and this is what they're currently using today. So this is an example of what a dashboard looks like. It's sanitized for obvious reasons, but you can see that there's the swim lanes there, and it allows you to track risk over time. Or those swim lanes actually show you what the risk score was. So it's hard to see on here, but it says 5 on the vulnerability, and then on the left-hand side, it's the IP address for that host. If I was to click on that specific IP address, in the bottom-hand corner, there's something called saved search, and you can filter down. It'll show you the plugin name, what the CVSS score originally was, and then what your custom risk score is, and you can take action on it. It has a plugin name and then what the plugin output was as a result of the scan. So very context-rich, very helpful, and it's better to invest time up front, and so you can save time when it really counts. Actionable next steps are to set up VulnWhisperer to start ingesting your vulnerability scans. Right now, if you're using Nessus, that's all you have. You can create custom risk scores. So go through your enterprise, find out which Nessus plugins are not applicable to your organization, and then if you can disable those in Nessus, great, or you can create a custom risk score inside of the Logstash config. You want to name scans by site, and or even just like you can do it by location, right? If you have global or regional offices, you can say this scan is for a small city in Brazil. Or you can make it very specific and create your own Grok filter. Create tags for your organization's most important assets, so identify all your critical assets, and then you can say, these critical assets have the highest vulnerabilities, we need to go immediately patch those. And lastly, I encourage everyone here to give back to the community. I spend a lot of time after work working on this to try to make it to give back to the community because we have a tough fight ahead of us, and I know we're all here working hard every day. So thank you for letting me be part of the community, and thank you for listening to my talk.